Question 11. ATP can be produced in various ways. Each stage of respiration contributes to the production of ATP. Describe the production of ATP by substrate level phosphorylation in different stages of respiration with reference to the number of ATP molecules produced. So we can start off with glycolysis, where there are 2 molecules of ATP produced from glycolysis. So the glucose is broken down into triose phosphate. It will use 2 lots of ATP in order to do this, and it goes from a 6-carbon compound into 2 lots of the 3-carbon, which is triose phosphate. We've then got the substrate level phosphorylation, because ADP, 4 lots of it, will combine with the Pi to create 4 lots of ATP. So the triose phosphate will then produce 2 lots of pyruvate, and this is substrate level phosphorylation. So there is a net gain of 2 lots of ATP, because although 4 have been produced, 2 were used in the earlier stages of glycolysis. So glycolysis on its own will produce 2 lots of ATP. So the mark scheme gives you credit for recognising 2 lots of ATP formed from glycolysis when there is the breakdown of triose phosphate when it is converted into 2 lots of pyruvate. You could also explain where that comes from, so the net gain being 2 because 4 are made but 2 are produced. You then get the pyruvate going through the link reaction to create the acetyl coenzyme A. However, there is no ATP produced during this. The acetyl coenzyme A is then going to enter into the Krebs cycle. So in the Krebs cycle, the acetyl coenzyme A binds with the 4-carbon compound of oxoaloacetate and will produce a 6-carbon compound. Then decarboxylation will occur, carbon dioxide will be lost to create the 5-carbon compound. Decarboxylation will happen again, which will then regenerate the 4-carbon compound, which can then bind again with further acetyl coenzyme A molecules. Substrate level phosphorylation occurs because 1 lot of ATP is produced during each cycle of the Krebs cycle. So 1 ATP is produced per turn of the Krebs cycle or per acetyl coenzyme A entering the cycle, and this is when the 5-carbon compound is converted to the 4-carbon compound or the oxoaloacetate.